This is a diagram of our architecture's infrastructure. When the server starts up, the first thing that happens is it will take all the React source code that we used and compile it into JavaScript. React is a framework for creating web UIs. The reason why we need to compile it down to raw JavaScript is because React uses special syntax called JSX. This makes it a lot easier to develop, but it is not supported by browsers. So we use a tool within Node.js to compile the JavaScript into ES5, which any modern browser can run. Once this happens, it is complete, and Node does not need to do anything else. It can just shut down. All the core application logic is handled by Flask, which is a Python web server gateway interface. The application handles all the logic whenever the user makes a request, whether they want to get a page, log in, create an account, save their scores for a game, anything like that. The web server gateway interface application is hosted by gUnicorn, which is a web server gateway interface server. This is what handles all the internet requests and makes sure that everything happens smoothly with the Flask application. gUnicorn is what communicates directly with the browser, where the user will be using our website. In order to store persistent state, such as user accounts, as well as game scores, we use a database called PostgreSQL. The reason we need to store it in a database and not in the Flask application's memory is if the server ever goes down, such as for maintenance or because of an unexpected crash. By storing it in a database, all the state can be reloaded, and a modern database such as PostgreSQL ensures that the data will not go into the database in a half-submitted format, which helps ensure that the data will not be corrupted. A problem we experienced when doing development was the original way we had our React compiler set up. Originally, it was compiling each individual file into its own separate JavaScript file, and this was working. The problem is that it was putting the weight on the browser to sort of combine it all together and make sure each part works together. This isn't something that browsers were designed to do, so the errors that we were getting whenever the problem was occurring were kind of vague and cryptic, not giving us much help in terms of debugging and fixing. So instead, we included a bundler into our Node.js compiler. The bundler would be able to take all of our React source code and combine it into a single JavaScript file. That single JavaScript file could then be run by the web browser. If there were any errors that could be detected at compile time, such as incompatibility between files, the Node.js compiler would detect them and flag it and give us a very helpful error message to allow us to fix it instead of having to rely on the errors that we got from the browser.